Chapter 1. Whispers Beneath the Stars. Long before cities rose, long before the written word, there were the stars. Each night they spilled across the sky like soft embers floating in an unseen wind. Ancient people, shepherds, travellers, elders sitting by fires, looked up in quiet wonder. They did not have telescopes or maps, only their eyes, their stories, and their questions. What are those lights? Why do they move? Why do some vanish, only to return months later? In the stillness of early human life, these questions stirred. Patterns in the sky became guides. For time, for harvest, for hunting. The phases of the moon marked cycles. The rise of certain stars foretold the coming of rains. Slowly, people began to listen to the sky as if it whispered truths. They named constellations after animals, gods, and legends. The stars were not just beautiful, they were alive with meaning. The night sky became a canvas of memory. Elders passed stories down of bears that chased across the heavens, of mighty hunters frozen above, of tricksters hiding behind clusters of light. These tales were not just myths. They were maps. They were calendars. They were the earliest form of science. Wrapped in story and wonder, from deserts to forests, from icy plains to riverbanks, the same stars watched over humanity. And across all lands the same questions emerged. Where does the sun go at night? What lies beyond the moon? Who lights the stars? We don't know the names of the first people who asked, but their questions still echo in every telescope, every spacecraft, every child who looks up and wonders. In asking, they began the story of the solar system. A story not of answers, but of searching. The silent sea of light, as centuries passed, a quiet understanding took root. The stars, once seen as tiny holes in a dark dome, became something more, not just ornaments for the sky, but distant fires, suns perhaps, like our own. The night was no longer a ceiling, but a sea, vast, deep, and unknown. Ancient Greek thinkers began to wonder if Earth was not the center of all things. Perhaps the planets were worlds, perhaps the stars were places. The sky grew wider with every thought, but there was no noise, no signal. The stars did not speak. They shimmered and shifted but gave no answers. This silence only deepened the mystery. It was like watching a lighthouse from a distant shore. You see the light, but not the keeper. In Babylon, astronomers kept careful records of the sky. They charted the paths of wandering stars, planets like Mars and Venus. These bodies did not stay fixed like the rest. They moved, curved, danced. What were they? In India and China, scholars built observatories and studied eclipses. They saw patterns in what seemed like chaos. They understood that the sky was a clock, and though it ticked slowly, it was precise. Still, the stars remained far, too far to touch, too far to hear. But the idea had taken root. The sky was not just decoration. It was a place with rules, with order, perhaps even with other worlds. So humanity kept watching and waiting. The silence of space did not mean emptiness. It meant possibility. It meant that the universe had not yet revealed its voice. Mapping the unknown with time, curiosity grew sharper. Stone tools gave way to compasses and sextants. Observatories rose across empires. The desire to map the sky became a quiet obsession. In Alexandria, Ptolemy drew charts that placed Earth at the center. His model was elegant, detailed, and for centuries it shaped how people imagined the cosmos. But it was flawed. Then came Copernicus. Quietly, he proposed something bold, that the sun, not Earth, was the center. At first, the idea felt wrong. It unsettled centuries of belief. But slowly it began to make sense. The dance of planets aligned, the odd paths of Mars and Venus could be explained. The map was redrawn. Galileo pointed a telescope to the sky. He saw moons circling Jupiter, craters on the moon, and stars too faint for the naked eye. The heavens, once thought to be perfect, were full of marks, shadows, and movement. They were real places with depth and change. In Persia, Ulugh Beg created star catalogues more accurate than Europe had ever known. In the Islamic world, scholars preserved and expanded the maps of earlier civilizations, adding new stars and refining models. Every chart was a question made visible, every measurement a whisper of understanding. Slowly, the solar system began to take shape. The planets were named, their orbits tracked. The sun took its rightful place at the center. But it was not just science, it was wonder. People drew these planets with care. They imagined their surfaces, they guessed at their winds, their moons, their colors. Even without visiting, they dreamed. Mapping the sky was more than observation. It was an act of connection, a way to bring the distant closer, to turn the unknown into something softly familiar. Dreams beyond the horizon. By the time telescopes dotted mountaintops and books filled shelves with star charts, a quiet dream had taken hold, not just to observe the stars, but to go to them. It started as imagination. Poets wrote of flying chariots and stairways to the moon. Writers penned stories of journeys beyond Earth. These were not predictions. They were wishes. Hope shaped into words. Then came the machines. Rockets rose from the ground. Satellites circled the globe. The dream became motion. In 1957, a small metal sphere named Sputnik beeped from orbit. It was a soft sound, but it changed everything. Humanity had placed an object in space. The sky was no longer untouchable. Soon, astronauts followed. Footprints marked the moon. Rovers rolled across Mars. Probes passed by Jupiter, Saturn, Neptune. Voyager left the solar system entirely, still sending whispers home. But even now, the dream remains gentle. It does not shout. It lingers in classrooms, in documentaries, in quiet late-night thoughts. What else is out there? Could we live on another world? Are we alone? The solar system is not just a group of planets, it is a trail of questions, each one leading to the next. Each one rooted in those first stargazers who looked up and asked, "Tonight the stars still shine." Silent. Patient. And somewhere, someone is looking up and dreaming, just as they always have. Chapter 2. The Sun, Heart of the Solar Family. Long before there were planets or oceans, long before life ever stirred or skies turned blue, there was only dust, cold, silent, and adrift in a quiet corner of the Milky Way. In this dark space, clouds of gas floated for millions of years, their particles untouched, their motion slow and dreamlike. But gravity, always patient and always working, began to gather the dust. It pulled inward, folding space into itself. Little by little, what was once scattered began to come together, tighter and tighter, until the weight of it all could no longer be ignored. Deep inside this growing sphere of gas, pressure rose. The temperature climbed. At first, there was only the faintest glow, a whisper of warmth inside the cold universe. But as more matter fell in, the core burned hotter, reaching the edge of something extraordinary. And then, it happened. In a moment, both silent and spectacular, hydrogen atoms began to fuse. This process, nuclear fusion, unlocked a power that had been sleeping inside the cloud all along. The sun had been born. It didn't roar into life. It rose slowly, like a candle finding its flame. Its light began to stretch outward, touching the edges of space around it, changing everything in its reach. It was the beginning of day in a universe filled with night. This newborn star didn't yet have planets circling it. They would come later, formed from the leftover dust and stone that hadn't joined the sun's core. But even without them, the sun was already shaping its family, calling them in with its light and gravity. In the quiet of early space, one small star began to shine, and that single light would one day warm the skin of children on earth, spark the oceans to dance, and draw shadows from trees that had not yet grown. The sun was awake. The furnace of life. At the heart of the sun, deeper than any eye can see, a fire burns that has never gone out. It's not the kind of fire we know. There is no smoke, no wood, no flame. Instead, it is a furnace of pure energy where atoms collide with such force that they transform. Hydrogen becomes helium, and in that change, light is born. This light begins its journey in the sun's core, a place where temperatures reach over 15 million degrees Celsius. But it does not rush to the surface. Instead, it travels slowly, bouncing and weaving through layers of solar matter. Some of the light takes hundreds of thousands of years just to escape the dense middle. It's as if the sun keeps each photon for a while, warming it with care before letting it go. Once free, that light bursts out into space. In a little over 8 minutes, it reaches Earth. That journey is so fast it seems like nothing. Yet it brings everything. The sun's light touches oceans and deserts. It melts ice, stirs wind, paints flowers in bloom. Every tree reaching upward, every fish swimming through warm tides, every breath we take, they are all stories written by sunlight. The sun is not only light, but also warmth. It carries heat across millions of miles of cold emptiness. Even planets far from it feel its touch. Mars, with its red dust, shimmers in its glow. Jupiter's swirling clouds reflect its light. Even distant Pluto, tiny and cold, sees the sun as more than just a star. It sees a distant spark it once circled more closely. Without this constant fusion, without this endless giving of light and heat, the solar system would be a frozen silence. Earth would never have found its voice. Life would never have learned to grow, and humans, who one day would look up and wonder about the stars, would never have opened their eyes. This invisible fire at the center of our star is the quietest miracle we know. Every second, the sun turns millions of tons of matter into energy, and it has done so every second for billions of years. A constant companion, we rise with the sun, not just in the morning, but in our history. From the earliest days of humanity, its light has been a rhythm, a guide. The sun is more than a star. It is a companion that has never left our side. On Earth, we measure time by the sun's path. Days begin when it rises. Nights fall when it disappears. Seasons shift as our world tilts and turns, all under the sun's steady gaze. Ancient people built temples that followed its movement. Farmers watched its light to know when to plant. Sailors steered their ships by its place in the sky. Poets wrote of its warmth. Children drew it with smiling faces. Every planet in our solar system, no matter how far, feels the sun's pull. Mercury, the closest, dances in its glow, scorched and swift. Venus, wrapped in clouds, glows golden with its light. Earth, with its oceans and skies, turns slowly, kissed by sunrise and sunset. Mars watches from afar, its surface carved by winds, shaped by solar heat. Even the outer planets, giants like Jupiter and Saturn, are held in place by the sun's gravity. They may be far, but they circle with the same loyalty. And beyond them, icy worlds drift through the shadows, still tethered to the sun's reach. Even the smallest speck of rock, the faintest dust, belongs to its family. The sun keeps them all. Its gravity is the glue of the solar system. Without it, every planet, moon, and comet would drift away into the dark. But because of the sun, there is order. There is music in the movement. Each orbit is a note in a grand, silent song, one the sun has conducted since time began. We often take its presence for granted. It is always there, after all. But when we pause and look, really look, we see not just a bright circle in the sky, but a friend, a guardian, a quiet power that has watched over our world since before it had a name. The long, gentle burn. The sun is not in a hurry. Stars live on a different clock than we do. While a human life spans decades, the sun's life is counted in billions of years, and for most of that time it has done the same thing, burn gently, steadily, and without complaint. It is a peaceful kind of power. Every second it turns mass into light, not in bursts, but in calm waves. It doesn't flare in rage, it doesn't dim in sadness, it simply continues, giving without asking, shining without needing. We are in what scientists call the sun's main sequence. This is its prime, a long middle chapter in its life where it glows with balance. It has been in this phase for about 4.6 billion years, and it will stay this way for several billion more. That means the Earth, and all of us living here now, were lucky enough to be born in the calm. But like all things, the sun's journey will change. Far in the future, so far it feels more like myth than fact, the sun will begin to shift. It will grow larger, redder, softer. It will become what's known as a red giant. During this time, its outer layers will expand, reaching out toward the planets. Mercury and Venus may be swallowed. Earth's fate is uncertain, but even then the sun's light will not end in violence. It will end in release. Eventually, the sun will shed its outer shell, letting go of its past. What remains will be a white dwarf, a quiet, glowing ember, no longer burning, but still warm. It will sit in the dark like a memory, like the last note of a song that once filled the air, and even then, its story will continue. The light it gave during its life will still travel. It will still touch the edges of the galaxy. It will still shine on planets long gone, in photos we take, in warmth we remember. The sun's journey is not just about heat and light. It is about patience, about steadiness, about giving every day without asking for applause. It is the kind of power we rarely notice but always feel. And in the quiet moments before sleep, when the world is still and the sky is dark, we can close our eyes and know, out there in the silence, the sun still burns, still watching, still warming, still waiting. Chapter 3. Mercury, the burned and broken world. In the silent theatre of space, there is a world that never strays far from the sun's blinding glare. Mercury, the smallest of the 8 major planets, dances dangerously close to the star that gave it birth. Its orbit is tight, its pace swift. A year on Mercury lasts only 88 Earth days, yet its days and nights stretch long and strange. Because of the way it spins and moves, one side of Mercury can sit under the sun's relentless heat for what feels like weeks, while the other side remains frozen in darkness. There is no soft morning or gentle dusk here, only extremes. In this, the sunlight, temperatures rise past 800 degrees Fahrenheit, enough to melt lead. Yet just steps into the shadows, the cold drops to hundreds of degrees below zero. It is a land of blazing heat and bitter cold, all in one breathless cycle. Mercury has no thick atmosphere to soften this harsh rhythm. There's no protective blanket to hold in warmth, no clouds to scatter sunlight into golden skies. Instead, its thin exosphere, a wisp of gas barely clinging to the surface, leaves the planet exposed. Here, the sun reigns without resistance, striking the ground with the full weight of its radiation. But Mercury does not run from the sun. It stays in its orbit, locked in a strange rhythm, not quite spinning in time with its path, but not resisting it either. It turns slowly, facing the light and the dark in long, lingering moments. There are no winds here, no rain to wash away time. Only silence, scorched rock, and the endless pull of gravity holding it close to fire. To look at Mercury is to see a world that chose the edge. It exists not in balance but in contrast, not in comfort but in endurance. And still, it moves again and again around the sun that both created and torments it, the battered surface. If you could walk across Mercury's landscape, you would see a world shaped by violence. The ground is covered in craters, some shallow, some deep, some stretching for miles. There are no forests, no oceans, no signs of life, only a rocky skin marked by the memory of countless collisions. These craters tell a long and lonely story. For billions of years, asteroids and comets have struck Mercury's surface without resistance. With no thick atmosphere to burn them up, every piece of debris that passed too close made it to the ground, and each time it left a scar. Some of these craters are so old that they've been hit again and again, creating layers of damage. Rings within rings, shadows within shadows. There is one crater, the Caloris Basin, that stands out among the rest. It's one of the largest impact craters in the solar system, stretching about 960 miles across. When the object that created it hit Mercury, the shock wave was so powerful that it rippled through the entire planet, breaking the crust on the far side. That moment, frozen in stone, shows just how thin Mercury's skin really is, and how deeply it can be wounded. Between the craters, you'll find plains of hardened lava, remnants of volcanic activity long ago. Though Mercury is quiet now, its past was not. It once had internal heat that pushed molten rock to the surface, spreading out across the land and filling in the older scars. But over time, that energy faded, the lava stopped flowing, and the planet settled into stillness. There are cliffs, too, some that rise for hundreds of miles. These cliffs formed when Mercury shrank. As its core cooled, it pulled inward, causing the surface to buckle and crack. It's as if the planet, once full of motion, exhaled a final breath and tightened its grip. Now the surface remains frozen in that last gesture. There is no weather to wear it down, no rivers to wash it clean. The craters, the cliffs, the broken plains, they are all still there, unchanged and undisturbed. Mercury remembers everything. The heart, exposed beneath Mercury's battered skin, lies one of its greatest mysteries, a massive iron core that takes up most of the planet's volume. Compared to its size, no other rocky planet has a heart so large. It's as if Mercury was meant to be bigger, fuller, and something stripped it down, leaving only its inner strength behind. This oversized core hints at a violent past. Some scientists believe that in its early days, Mercury was struck by a massive object, a blow strong enough to rip away its outer layers. What remained was the dense, heavy center, a planet reduced to its foundation. Others think the Sun itself may have played a role, blasting Mercury with such heat and force in its youth that its lighter outer crust evaporated into space. Whatever the cause, the result is the same, a world with a core exposed. Mercury's surface is thin, fragile, just a shell over its deeper self. And that shell still shifts. In some places, giant faults mark where the crust has moved, folding over time as the planet continues to cool. These are not fast changes. They happen over millions of years, slow and steady like a breath drawn in stone. Despite its small size, Mercury has a magnetic field, a weak one, but still surprising. It is thought to come from its liquid outer core, still swirling deep inside. This means Mercury is not entirely silent. It still has motion, deep beneath its quiet face. It still holds heat. It still pulses in ways we can barely measure. This heart, heavy and enduring, may be the reason Mercury has survived so long so close to the Sun. While its crust is battered and broken, its core is strong, a dense reminder of what it once was and what it continues to be. A survivor in silence. Mercury has no moons to keep it company. No clouds to dance across its skies, no air to carry sound. It is alone, circling the Sun in a rhythm older than memory, and yet it endures. This is not the endurance of a vibrant, changing world. It is the endurance of stillness, of presence. Mercury has survived not because it thrives, but because it remains. It holds its orbit, follows its path, and accepts the heat and the cold without question. In its silence, Mercury speaks to us. It tells the story of a solar system born from dust and flame, of chaos, impact, and quiet strength. It is the first planet in line, the one that feels the sun's light most sharply, the one that bears the weight of being closest. And still it turns. Even today, with our spacecraft watching from afar, Mercury stays mysterious. It hides its past. Beneath layers of stone, it offers no easy answers, no bright blue oceans or clouds to draw the eye. And yet it holds a power all its own, the power of a world that does not need to shine to matter. In many ways, Mercury is a mirror, not of what is, but of what has been. It reflects the raw beginning of our solar system, the violence and wonder of formation, the quiet endurance of time. It shows us what it means to exist at the edge, where survival is not about beauty or abundance, but about staying. And so Mercury continues, small, scorched, and strong. A planet burned by the sun, broken by the past, but never gone. Its story is not loud, it does not beg to be known, but in the stillness of space, Mercury remains a survivor in silence. Chapter 4. Venus, Dreams beneath the clouds. High above the surface of Venus, thick clouds swirl in a tight embrace. They stretch across the planet like a curtain drawn against the stars, hiding what lies beneath. For centuries, these clouds kept Venus a secret. From Earth, it looked calm, a soft, glowing pearl in the night sky, a twin to our own world in size and shape. A sister, perhaps, but sisters are not always alike. When early astronomers turned their telescopes to Venus, they saw only brightness. No mountains, no shadows, just layers of cloud, perfectly smooth, perfectly closed. The mystery deepened what was behind the veil. It wasn't until the space age, and when our machines flew close and some even landed, that we saw the truth. And the truth was not gentle. Beneath those beautiful clouds is a world ruled by fire. The sky rains acid, the winds scream at hundreds of miles per hour, the surface is hot enough to melt lead, the clouds are not soft, they are poison, made of carbon dioxide and sulfuric acid, thick and heavy, pressing down on the planet with more than 90 times the pressure of Earth's atmosphere. There is no blue sky on Venus, no quiet breeze, no soft soil, just burning rock, choking heat, and skies that never clear. Yet even in this harshness, Venus remains haunting. Its mystery is not gone, only changed. Because now we ask different questions. How did it come to be this way? Was it always like this? Or was there, long ago, a different Venus, one we might recognize? Echoes of a lost ocean. Long ago, before the heat took over, some scientists believe Venus may have been very different. They think it might have had water, oceans even, just like Earth. The idea seems impossible now with its furnace-like surface and air thick with gas. But clues remain. When we study the chemicals in Venus's atmosphere, we find strange signs. The ratios of hydrogen and its heavier form, deuterium, suggest that water was once here, and then vanished. Not all at once, not in a great flood, but slowly, bit by bit. As the sun warmed Venus, its oceans may have started to steam, sending vapor into the sky. That water, floating high in the atmosphere, was broken apart by sunlight. The hydrogen drifted into space. The oxygen may have reacted with surface rocks disappearing into the ground. And just like that, the water was gone. If that ocean ever existed, it is long lost now. There are no rivers left to mark its path. No seashells in the stone. But the shape of the land, old valleys and basins, hints at a past that was once more familiar. There is poetry in that thought. That two planets, born so close together, formed with such similar size and structure, might have walked the same path. For a while, maybe Venus had clouds that rained. Maybe it had lakes that shimmered. Maybe it had gentle winds and a soft dawn. But something changed, and in that change, the dream of Venus faded. Still we look for it, in every radar image of its surface, in every whisper of data from old probes. We search for the echo of a world that might once have been alive with water, with weather, and with wonder. A runaway world. To understand Venus today is to understand a world out of balance. On Earth, our atmosphere holds in warmth from the sun. It's called the greenhouse effect, and it keeps our planet comfortable. But on Venus, that same effect went too far, much too far. The carbon dioxide in its air trapped more and more heat. Temperatures climbed, oceans, if they were there, boiled away. The ground grew hotter, the air thicker. More heat meant more evaporation, which added even more carbon dioxide. It was a cycle that fed itself, a spiral without escape, and so Venus burned. Today its surface is hotter than any other planet, hotter than Mercury, even though Mercury is closer to the Sun. The clouds, thick with sulfur and acid, swirl fast, circling the planet in just a few days, while the surface spins so slowly it barely turns at all. The atmosphere presses down like an ocean of gas, and lightning crackles through the clouds with eerie flashes, lighting up a world that has never known calm. This was not sudden. It took millions of years, but once it started, it could not stop. Venus shows us how small changes can lead to great consequences. A little more heat, a little more gas, a little more time, and a world can shift from gentle to deadly. What makes it even more haunting is that the ingredients of Venus are not so different
from Earth's. It is a world built of rock and metal.
A world born near the same star. A world that, in another life, might have shared more than just our shape. But its path diverged. And now it reminds us of how fragile balance can be, and how easily it can be lost. Lessons in fragility. Venus is more than a mystery, more than a story of lost water or runaway heat. It is a mirror, a warning wrapped in beauty and fire. When we look at Venus, we see what can happen when balance breaks, when a planet's air changes too much, when its heat is trapped, when its oceans vanish. These are not just distant fears. They are whispers, soft but serious, reminding us that the things we take for granted, breathable air, flowing water, blue skies, are not guaranteed, they must be kept. Earth is not immune. Our own climate shifts with each choice we make. And while we are far from becoming Venus, the steps toward imbalance begin quietly. They begin with warming oceans, rising, gases, lost forests, and then they grow. Venus cannot tell us how to fix Earth, but it can show us what happens if we don't. It can show us what's at stake. The silence on its surface is not peaceful. It is the silence of a planet that no longer holds life. Clouds are not just cover. They are the final chapter of a story that might have been like ours. Still, there is something enduring about Venus. It may be harsh, but it is not broken.
It continues to turn. It holds its orbit. It catches the sun's light and reflects it back to us, shining in our night sky like a soft lamp. Distant but close, dangerous but beautiful, and perhaps that is its final gift, to remind us that
beauty can hide warning, that heat can come slowly, and that every world, even one born in the same family, you must protect its balance or lose it. As we sleep beneath our own sky, cooled by breezes and held by oceans, Venus spins beneath.
A cloak of clouds. Its voice is silent, but its lesson speaks, a whisper across space, a dream beneath the clouds.
Chapter 5. Earth, a fragile miracle. In the wide, spinning clockwork of our solar system, there is a narrow space where warmth is just enough, and cold is not too much. This is the Goldilocks zone, not too hot, not too cold, and Earth rests
right in the heart of it. Not by plan, not by will, but by quiet chance. It is the third planet from the Sun, floating 93 million miles away. Far enough that the Sun's heat doesn't burn, close enough that it doesn't freeze.
In this rare place, water can flow in its liquid form. Ice melts, clouds rise, rain falls. This is not common. On Mercury, the heat is too harsh. On Venus, it's too heavy. On Mars, the cold bites deep, but Earth is balanced, this perfect. Distance means more than just comfort. It means life. It means that the warmth of the sun can stir oceans, wake seeds, and soften the soil. It means that ice can form and melt again, shaping rivers, carving valleys, feeding lakes. It means air can move, carrying pollen, lifting wings, cooling skin. From this position, Earth receives just the right gift, energy, not too fierce, not too faint. Yet this balance is delicate. A small shift, closer or farther, and the world would change. Earth is not guaranteed. It is fortunate. Wrapped in this gentle distance, Earth grew not just as a planet, but as a cradle, a place where life was not only possible, but plentiful, where bacteria swam, where trees reached, where creatures took breath. All of it, every bird, every wave, every step, rests on this invisible line drawn in space. A silent, stable gift. The breath of the world air is something we rarely see, yet it moves through all of us. We breathe it without thinking, but where did this breath come from? Earth's air was not always kind. In its early days, the planet's skies were filled with harsh gases, thick with carbon dioxide, sulfur, and steam. It was a place without breath, without rest. But slowly the world changed. Tiny life appeared, simple, quiet cells floating in ancient seas. Some of these cells, known as cyanobacteria, did something remarkable. They took in sunlight and water and released something new: oxygen. For millions of years they did this over and over, filling the ocean, then the sky, with the gas that would one day fill our lungs. And so the air began to shift, from poison to possibility, from silence to song, but the atmosphere wasn't built by bacteria alone. As plants grew, they joined the work. Trees, mosses, grasses, each one inhaling carbon dioxide and exhaling oxygen. A quiet rhythm, a natural exchange. The oceans, too, played their part. Waves absorbed gases, tides stirred nutrients, plankton danced in the light. Together the land and sea began to write the atmosphere we know today. Earth's air is not just a layer. It is a living blanket. It keeps the planet warm, shields it from harmful rays, carries water across continents. It holds the scent of flowers, the flight of birds, the sound of laughter, and every part of it, every breath we take, is the result of a long, invisible teamwork between the green and the blue. It is a shared gift, given freely, kept gently. Seasons of change. Look up from Earth, and the sky may seem still. But nothing here stands still. The world turns, it leans, it circles, and from these slow, graceful movements come the seasons. Soft steps in a quiet dance. Earth is tilted. Not much. Just a gentle lean, about 23.5 degrees. But that small tilt makes all the difference. As the planet travels around the sun, this tilt means that different parts of the world get different amounts of sunlight at different times. When the northern half leans toward the sun, it's summer there. When it leans away, it's winter. And so it goes. Spring, summer, autumn, winter. A pattern as old as time. These changes bring more than just shifts in weather. They bring rhythm. Seasons help plants know when to grow and when to rest. They guide animals in migration and hibernation. They shape the way cultures have lived. When to plant, when to harvest, when to gather, when to stay close to fire. Even Earth's rotation, one full turn every 24 hours, matters deeply. It creates the cycle of day and night. It stirs winds, shapes tides, and marks time in ways we barely notice. Every sunrise is part of this spin, every sunset a soft reminder that motion never ends. And as Earth orbits the Sun, not in a perfect circle, but in a gentle oval, it adds more layers to the seasons. Slight changes in distance, in tilt, in timing, all blending together to create a planet where change is constant but never chaotic. Seasons remind us that life does not stay the same. It grows, it rests, it shifts. And in those shifts, beauty is born. The web of life. From the highest mountain peak to the deepest ocean trench, Earth is alive, not just with animals and people, but with systems, connected, quiet, and shared. This is the web of life. Forests breathe with the sky. Trees pull in carbon dioxide and give back oxygen. Their roots dig deep, holding soil in place, feeding. Fungi sheltering insects, birds nest in branches, rain gathers on leaves, and when trees fall, they return to the earth, becoming food for the next. In the oceans, currents move like veins. They carry warmth, stir nutrients, and guide the migrations of whales and fish. Coral reefs bloom beneath the surface, cities
of stone and colour, alive with creatures too small to see and too rare to name. Seaweed sways with the tide, feeding life from the sun's touch. Above, the skies are not empty.
Clouds drift with purpose, winds carry seeds, bees fly from flower to flower, weaving together gardens. Even the air holds life, spores, pollen, tiny travellers on invisible roads. Everything is linked. A butterfly in one forest might shape the wind in another. The melting of ice in the far north can raise the seas in the far south. A drop of water that falls as rain may become part of a river, a plant, a drink, or a tear. Humans are part of this web too. We build, grow, sing, and dream. But we also depend on bees, on trees, on clean water, and clear skies. We are not outside nature, we are inside it, woven into the same threads. And like any web, this one is fragile. Pull too hard in one place, and the ripples travel far, but care for it, gently, kindly, and it holds, it lasts. Earth is not only a planet, it is a system of breath, of light, of balance, a miracle made of millions of small, living pieces, held together by connection, moved by time, loved quietly by all who call it home. Home. Chapter 6. The Moon. A quiet companion. Long before it lit the night skies or pulled the tides, the moon was part of something else, part of Earth, part of a world not yet whole. Its beginning was not peaceful. It was born in fire. Billions of years ago, Earth was young, still soft, still forming, still finding its shape. The solar system was a dangerous place then, filled with debris left over from creation. Giant rocks, some the size of planets, moved through space without warning or mercy. One of them, a Mars-sized body we now call Theia, crossed paths with Earth. And in a moment that changed everything, it struck. The impact was massive, more violent than anything we can truly imagine. Theia didn't just hit Earth, it blended with it. The collision tore away pieces of both planets, sending molten rock and metal into orbit. For a time, Earth was surrounded by a ring of glowing debris, a fire ring circling a bruised world. But from that chaos, something new began to form. The broken pieces, still hot from the collision, began to gather. Gravity pulled them close, and bit by bit, They shaped themselves into a sphere, not a perfect one, not right away, but slowly, steadily, this sphere cooled, hardened, and became the moon. It wasn't an outsider. It was a piece of earth reborn in the sky, and though its origin was violent, its presence would become calm. What began in a blast would become one of the most steady forces in the solar system, a companion shaped by collision, now defined by quiet. The keeper of balance. The moon doesn't make a sound, but its influence is powerful. Like a silent guardian, it keeps Earth in place, holding the planet's rhythm with an invisible hand. One of the most important things the moon does is stabilize Earth's tilt. Our planet doesn't stand straight, it leans slightly about 23.5 degrees. This tilt is what gives us seasons, but without the moon, that tilt could shift wildly. Over time it might wobble more, spinning our climate into chaos. But the moon's steady pull acts like a weight, keeping Earth's lean balanced and calm. This balance allows life to flourish. Seasons change gently, weather moves in patterns, ecosystems can grow, rest, and renew. The moon may not speak, but it keeps the world steady enough for life to listen, grow, and continue. And then there are the tides, the gentle rise and fall of Earth's oceans, pulled by the moon's gravity. As the moon moves through the sky, it tugs at the water below. The oceans stretch toward it, creating waves that breathe across shorelines. These tides shape coastlines, stir nutrients, guide migrations, and bring rhythm to marine life. The moon's effect on Earth is constant, quiet, and deeply important. It doesn't need light of its own. It reflects the sun softly. But its real strength is not in brightness. It's in presence. It is always there, watching, holding, balancing, this partnership, Earth and Moon move as one. Two worlds forever locked in a slow celestial dance. Silent watcher of history. The surface of the moon is quiet, but it holds memories. With no wind to erase, no water to wash away, no life to build or break, the moon is a time capsule, keeping the past as it was. Look closely at its face and you'll see the story written in stone. Craters, large and small, pockmark its surface. Each one marks a moment, a rock from space that struck and stayed. Some craters are billions of years old, untouched since the earliest days of the solar system. Others are newer, sharper, formed in more recent silence. Together they record a history Earth cannot. On Earth, time moves in layers. Rain falls, rivers carve, plants grow, and erosion softens every scar. But the moon has no such distractions. Its surface is still, its record uninterrupted. It remembers the impacts Earth has long since healed. It holds the tale of what the inner solar system was, a place of fire, dust, and constant collision. And it has seen us too. The moon watched as life began in Earth's oceans. It saw the rise of trees, the drift of continents, the fall of comets. And in the briefest flash of cosmic time, it saw something remarkable. Footsteps. In 1969, for the first time, a human stood upon the moon, looking back at the world from which they came. That footprint still remains, untouched by wind, unchanged by rain. It will stay for millions of years, a quiet mark of how far Earth's children had come. The moon records without judgment. It is not changed by what it sees, but in its silence it keeps every secret, a stony witness to all that passes by, a gentle light, night after night. The moon rises, sometimes full, bright, and round, sometimes just a sliver, sometimes gone from sight, but always it returns. A cycle as old as time, a comfort as old as dreams. Across every culture, every land, the moon has stirred emotion. It has been a symbol of beauty, mystery, longing and peace. People have written poems to it, sung songs under it, made wishes on its light. It has been a guide for travelers, a clock for farmers, a friend for those awake when the world sleeps. There is something deeply human about the moon. Though it is made of rock and dust, it reflects something more. Its light is not its own, but borrowed. Soft sunlight bounced back from its surface. Yet it is this very gentleness that makes it special. The moon does not blaze, it glows. In times of trouble, we have looked to it. In times of love, we've walked beneath it. It has shone on battles, on births, on farewells. It has been constant through every age, even as the world below changed. The moon reminds us of cycles amid to beginnings, middles and ends, of fading and returning, of light in darkness. It moves not quickly, but patiently, not loudly, but clearly. Its presence tells us that there is order in the sky and comfort in repetition. As we lie down to rest, the moon may be rising somewhere. High above oceans, forests and cities, it keeps its path. Unseen perhaps, but not absent. It is a quiet companion, never asking, never rushing, always shining. And though it was born in fire and shaped by impact, the moon has become a symbol of peace, a light not loud but lasting. Chapter 7. Mars. Echoes of Ancient Rivers. In the vast silence of space, Mars waits. Rust-colored and quiet, it spins beneath a thin sky of pink and gold. It is the fourth planet from the Sun, a lonely sphere half the size of Earth, with a surface that looks dry, dead, and still. And yet, beneath its cold crust, Mars holds a story that stretches back billions of years, a story written not in fire, but in ice, silence, and memory. Today, Mars is frozen. The air is thin and cold, barely able to hold heat. Temperatures drop far below freezing, and water, once common, can no longer flow across the ground. It clings to the poles as ice or hides deep beneath the surface in frozen lakes. The sky, once perhaps blue, is now hazy and pale. The planet no longer breathes the way Earth does, but it wasn't always like this. Long ago, Mars was warmer. Its core, now quiet, once burned with energy. That heat gave the planet a magnetic field, one strong enough to shield its surface from harsh solar winds. With that protection came an atmosphere thick enough to hold warmth. In those ancient days, Mars had rivers, maybe even oceans. Clouds may have floated overhead. Rain may have fallen on stone. Something changed. The heart of Mars began to cool. Its molten core settled. The magnetic field faded, and without it the solar wind stripped away the air. The atmosphere thinned, the pressure dropped, and the water, unable to stay in liquid form, disappeared. What's left now is the shell of what once was. A planet locked in stillness, holding the shape of its younger self. Mars is not dead, but it is sleeping. Its frozen heart beats slowly beneath layers of dust. Waiting, ghosts in the rock. If you follow the surface of Mars with patient eyes, you will find traces, quiet, stubborn clues of a vanished world. These clues are not loud, they do not move or shine. But they are there, carved into rock and shadow. The canyons tell the first story. Valles Marineris, the largest canyon in the solar system, stretches over 2,500 miles, long enough to span the United States. It cuts deep into the Martian crust, revealing layers of history. Some scientists believe this canyon formed as the planet's crust cracked and pulled apart. Others think water helped shape it, water that once ran along its walls, softening sharp edges into smooth curves. Then there are the riverbeds, dry, winding channels that snake across the plains. They look so much like rivers on Earth that it's hard not to imagine them flowing. But on Mars they are dry, dusty, and silent. Still, their shape speaks of motion, of water that moved quickly, cutting paths into stone. Some channels branch. Like veins, others gather into basins where lakes may have once shimmered. In certain craters, layered deposits hint at lakes that filled, dried, and filled again. And in the soil, minerals like clay and hematite whisper of watery beginnings. These minerals form in the presence of water, not in dry air or desert winds, but in lakes, underground springs and gentle rains. Even the rocks themselves bear signs of erosion. Rounded stones, shaped not by machines but by time and flow, lie scattered across the Martian floor. Ghosts of rivers long gone, smoothed by what once ran over them. Mars does not hide its past. It wears it like a scar. Each canyon, each layer, each broken stone is a memory of something soft that once moved over something hard. Of a time when Mars was not just red but blue. Dust and dreams, the red dust of Mars is more than color. It is a presence, fine, endless, and alive with motion. It moves with the wind, slips through cracks, coats every rock. It is iron-rich, giving Mars its signature hue, but more than that, it is a storyteller. Martian dust is light, easy to lift and difficult to put down. Winds whip it into storms that can cover whole regions, or sometimes the entire planet. These storms roll across the surface for days, even weeks. They darken the sky, hide the land, and blur the boundary between ground and air. The dust does not only hide, it shapes. Over time, these winds have carved and smoothed the landscape. Sand dunes rise and fall, craters fill and empty. Ridges change form. In this way, the planet continues to move, even if the motion is slow. There are places where the dust builds up in thick layers, burying the past. There are also places where it's blown away, uncovering features lost for eons. Rovers that land on Mars often spend time brushing dust from rocks, revealing their textures, their layers, their secrets. The dust is both blanket and barrier, covering history but preserving it too. In this ever-shifting desert, we send our machines. Rovers roll across the land, orbiters scan from above. They dig, drill, and photograph, trying to understand what came before and what might come next. Through red storms and silent plains, the dust of Mars becomes a canvas. And on it, we paint our questions. About time, about change, about place. The winds continue. The dust drifts, and beneath it all, Mars dreams in silence. Tomorrow's hope. For centuries, Mars has pulled at the human heart. From ancient stargazers to modern scientists, it has been a place of wonder, of fear, of curiosity. A red spark in the night sky, familiar, yet unreachable. But now that distance feels smaller. We've sent orbiters, landers, and rovers. We've mapped its surface, studied its weather, and listened for quakes beneath the ground. We've searched for signs of life, past or present, And in doing so, Mars has come alive again. Not in the way Earth is alive, but in the way a dream begins to breathe. Mars is dry and cold, yes, but it is also a place of promise. Its soil holds water ice. Its days are close to ours in length. Its gravity, though lighter, is enough to walk upon. And beneath its surface, protected from radiation and storms, there may be places where life could once have survived, or might survive in the future. For some, Mars represents science. For others, survival. A new world to explore, to learn from, to reach. It is not an easy dream, but it is a shared one. Human missions are being planned, habitats imagined, technologies tested. Slowly, we are learning what it might take to live there, to grow food, to breathe, to move freely. Not to replace Earth, but to extend its story. And in the sky, every night, Mars rises, a red light among stars, a constant, steady reminder of what lies beyond and what might lie ahead. Mars was once shaped by water. Now, it is shaped by hope. Hope. Chapter 8. The Asteroid Belt. Broken Dreams. Between the orbits of Mars and Jupiter, there exists a wide band of stone and silence. It's not a planet, but it could have been. This is the asteroid belt, a place of fragments, drifting pieces of rock that never became something whole, a place of broken beginnings. Long ago, in the early days of the solar system, the space between Mars and Jupiter held all the right materials to form a planet. Dust, metal, ice, everything needed was there. And yet no planet came to be. Why? The answer lies with Jupiter. Jupiter, the giant of our solar system, formed early and fast. Its immense mass gave it a gravity so strong that it disturbed the region nearby. As material in the asteroid belt tried to gather and grow, Jupiter's pull pulled it apart. Again and again, it stirred the soup of stone, never letting it settle. The forces at play were too great, the balance too fragile. Instead of becoming one world, the matter broke into thousands, large chunks, small slivers, icy bodies, metal cores, all now orbiting in their own quiet paths. No air, no seas, no sky. Just emptiness and echoes. This is the story of a planet that almost was. A dream paused in mid-creation. And yet, even in its unfinished form, the asteroid belt holds deep importance. These fragments, though small, are ancient, older than Earth, older than Mars. They are pieces of the original material, the first dust, from which all the planets were born. In this way, the asteroid belt is not a failure. It is a museum, a preserved page in the book of creation, a chapter left open, shattered stones. Float quietly through the asteroid belt, and you won't see chaos. You'll see stillness. Vast space separates these bodies, enough that spacecraft often pass through without danger. But scattered across this empty stretch are millions of objects, some as small as pebbles, others hundreds of miles across. Each one tells a story. Ceres, the largest of them all, is nearly spherical, a dwarf planet with hints of water ice hidden beneath its crust. Vesta, bright and scarred, shows signs of ancient lava flows. Smaller bodies like Pallas and Hygeia spin in odd shapes, fractured by impacts that shook them into what they are now. Some asteroids are metal, the remains of failed planet cores. Others are carbon-rich, black as coal, filled with the building. Blocks of life. These stones have been shaped by time. They've collided, broken, drifted, and rejoined. No winds smooth their edges, no rivers wash them clean. Their surfaces are raw, chipped, cracked, and cratered. And yet they remain. Some asteroids spin wildly, tumbling through space. Others are so loosely held together, they're more like floating rubble piles than solid rock. But even the smallest among them is a relic, a preserved memory of what once filled the early solar system. These are not just rocks, they are pieces of history. And in their silence they tell us how worlds begin, and sometimes how they fall apart. The harbingers. From time to time, the stones of the asteroid belt leave their place. Nudged by gravity, pulled by chance, they drift inward, toward the inner solar system. Some become meteorites. Some burn in Earth's sky. Others strike with force, reminding us that their stories are not finished. Asteroids are both threat and promise. They have brought endings and perhaps beginnings. 66 million years ago, a rock the size of a mountain struck Earth. The crater it left behind is now buried beneath the Yucatan Peninsula. That impact ended the age of dinosaurs. It sent dust into the sky, changed the climate, and rewrote the path of life. But asteroids have also brought water, carbon, and organic molecules, the seeds of life itself. In the early days of Earth, when our planet was hot and young, icy asteroids may have carried the elements we needed: drops of water, chains of carbon. Simple things that over time became complex. Some scientists believe that life, or at least its raw materials, may have begun in space. That comets and asteroids helped stir the pot. That what fell from the sky helped us rise from the sea. Asteroids are reminders of both danger and possibility. They move without intent, but
Not without meaning. What they carry depends on when and where they fall. They are messengers, and sometimes they deliver endings.
sometimes they bring the pieces of a new beginning. Guardians and wanderers, Earth moves in a busy neighborhood. Though we cannot see them, thousands of asteroids pass nearby, some safely distant, others uncomfortably close. We call them near-Earth objects. They are watched, tracked, and studied with care. Some are small, no larger than cars. Others could reshape continents. Most pass by quietly, unseen but recorded. A few make headlines. Every so often one enters Earth's atmosphere, burning bright as it falls, leaving trails of light across the sky. Yet Earth is not unprotected. Jupiter, the same planet that kept a world from forming in the asteroid belt, now acts as a kind of shield. Its massive gravity can pull in stray objects, sending them hurtling into the outer solar system, or into Jupiter itself. In this way, Jupiter acts like a guardian, catching what might have harmed us. But it also sends things our way. Its gravity is complex, protective, but not perfect. We also have technology, telescopes that scan the sky, satellites that monitor motion, plans to deflect, redirect, or prepare. These are the tools of watchers, people who know that Earth's safety is never guaranteed, but always worth protecting. And among all this motion, there are wanderers. Trojan asteroids travel alongside planets locked in their orbits. Others, called centaurs, drift between the outer worlds, neither comet nor asteroid, uncertain of where they belong. These are the drifters, pieces of rock that may have left the belt long ago, now finding new paths. Earth lives among these travelers. We are not alone in our orbit, not untouched by the past, but we are aware. And in that awareness there is strength. Chapter 9. Jupiter, King of the Planets. Far beyond the warm comfort of Earth's orbit, past the scorched sands of Mars and the broken stone of the asteroid belt, a giant began to form. In the early chaos of the solar system, clouds of gas swirled and thickened, drawn together by gravity's patient hand. Among these clouds, one grew larger than the rest, heavier, denser, more powerful. This was the birth of Jupiter. Jupiter didn't form like Earth, from rock and metal. Instead, it was shaped mostly from hydrogen and helium, the lightest and most abundant elements in the universe. It grew quickly, gathering mass until it became the largest planet in the solar system. In its early days, Jupiter might have burned bright, nearly crossing the line into becoming a second star, but it stopped just short. It never reached the pressure needed for nuclear fusion. Instead of shining with its own light, Jupiter became something else, a giant, cold and powerful, holding its own kind of fire within. Today, Jupiter contains more mass than all the other planets combined. Its surface, if it can even be called, that is not solid. The planet is a vast ocean of gas and liquid with no clear boundary between sky and center. Clouds of ammonia swirl through its upper layers. Deeper down, pressure crushes hydrogen into strange metallic forms. Heat rises from within, not from sunlight, but from the energy still trapped inside since its formation. Jupiter doesn't orbit the Sun like the others. It pulls slightly at the Sun itself, their gravitational tug creating a tiny wobble in the solar system's center. That's the power of Jupiter. Not just big, but influential. A force that shapes orbits, stirs moons, and holds entire worlds in its reach. In the dark, cold reaches of space, Jupiter rose like a sleeping colossus. Silent, massive, watching. The timeless storm swirling across Jupiter's southern hemisphere is a storm so vast that 3 Earths could fit inside it. It is called the Great Red Spot, a cyclone of crimson, orange and white, spinning endlessly in a slow-motion fury. This is no passing cloudburst. This is a storm that has raged for centuries. We first saw it clearly through telescopes in the 1600s, and though it has shifted and shrunk with time, it has never stopped. It spins counterclockwise with winds faster than any hurricane on Earth. Its color, a deep, rusty red, may come from chemical reactions in the atmosphere, sparked by lightning or sunlight, but no one knows for certain. Even now, the Great Red Spot keeps its secrets. Beneath its beautiful chaos is a storm system deeper than any found on Earth. Unlike hurricanes that fade over oceans, this storm has no sea to calm it. Jupiter's thick atmosphere feeds it endlessly. There is no land to stop its motion, only layers of gas swirling faster with depth, adding to its eternal dance. Around the Great Red Spot, other storms form and fade. Bands of color stretch across the planet, separating areas of rising and falling air. These bands rotate in opposite directions, creating friction at their edges. Lightning crackles through the clouds, and auroras shimmer at the poles. Silent. Waves of light caused by magnetic storms no human has ever felt. Jupiter's weather is alien, vast, intense, and eternal. And the Great Red Spot is its crown. A monument of motion, never still, never sleeping, a family of wonders. Jupiter is not alone. It travels through space with a retinue. More than 90 moons spin in its gravity. Some are small, no more than captured asteroids, but 4 of them stand apart. These are the Galilean moons, Io, Europa, Ganymede, and Callisto. Each one is a world unto itself, and together they form a family of endless fascination. Io is the most volcanic place in the solar system. Its surface is covered in lava flows, sulfur plains, and erupting geysers. This constant chaos comes from Jupiter's gravity. As Io orbits, it's stretched and pulled, its insides kneaded by invisible forces that keep its core hot. Volcanoes dot its landscape, spewing materials hundreds of miles into the sky. Europa, by contrast, is quiet. Its surface is a smooth, icy shell, white and cracked like an ancient marble. But beneath that ice, scientists believe, there is a vast ocean, twice as much water as all of Earth's combined. This ocean may be warmed by the same tidal forces that shake Io. And where there is water, there may be life. Europa is not just a moon, it is a question waiting. Ganymede is the largest moon in the solar system, even bigger than Mercury. It has a magnetic field of its own, strange for a moon, and a surface marked by ice and grooves. Beneath the surface may lie another ocean, hidden and deep. Ganymede is a giant among moons, a quiet world that carries both strength and mystery. Callisto, furthest from Jupiter, is ancient and scarred. Its surface is covered in craters, a history written in impacts. But beneath the damage lies calm, a stable world, less stirred by Jupiter's pull. It, too, may hold a subsurface ocean, quiet on the outside yet hiding depth within. Together these four moons are like planets in their own right. And in their company Jupiter becomes more than a giant. It becomes a system, a miniature solar family orbiting a world of gas and storms, protector of the inner world. Jupiter does not only shape its moons, it shapes the solar system itself. With its immense gravity, it acts as both shield and slingshot, protecting Earth from some dangers while redirecting others. In the early days of the solar system, when planets were still forming and collisions were common, Jupiter's influence helped clear space. Its gravity pulled in or flung out countless asteroids and comets, reducing the number of impacts on the inner planets. Even now it continues this role, capturing rogue objects, absorbing them, or bending their paths away from Earth. Every so often, a dark mark appears on Jupiter's cloud tops, the scar of a comet or asteroid that did not escape. These scars fade, but they remind us of the power Jupiter holds. In 1994, the world watched as fragments of comet Shoemaker-Levy
9 crashed into Jupiter. The explosions were larger than Earth itself.
But Jupiter absorbed the blow. A silent, massive wall between us and deep space, and yet Jupiter's gravity is not perfect. Sometimes it sends objects inward, pushing them toward Earth instead of away. Its power is complex, its effects unpredictable. It is both gatekeeper and gambler, guardian and guide. Still, without Jupiter, Earth might be very different, or not here at all. It watches from afar, massive and distant, not with intent, but with gravity alone. Its size gives it a role no other planet can fill. A king among planets, not only by name, but by nature. Jupiter does not shine with its own light. It does not host life as Earth does. But it holds a kind of majesty, a silent presence that shapes everything around it. Its storms rage, its
Moons drift, and its gravity reaches across the solar system. It is not just a world, it is a force. A reminder that in the quiet stretches of space, greatness can exist without sound, and power without violence.
Chapter 10. Saturn, rings of silent majesty. In the cold depths of the outer solar system, past the orbit of Jupiter, a quiet monarch drifts through space. Saturn, the sixth planet from the Sun, glides in a slow, graceful arc, wearing a crown no other world possesses. Its rings, vast and delicate, shimmer like frozen music around its pale golden body. From Earth, they appear as slender curves of light, but up close they are a complex system, wide, thin, and made mostly of ice. Each ring is a collection of countless particles, some as small as snowflakes, others as large as houses. These pieces spin in unison, kept in balance by gravity, light, and time. They do not touch, but they move together, like dancers on a mirrored stage. The rings stretch over 170,000 miles from Saturn's center, yet they are no more than a few hundred feet thick, so wide, yet so thin. They seem impossible, like something imagined rather than real, but they are real, and they are ancient. Scientists believe the rings may have formed from shattered moons or icy comets pulled too close to Saturn. Broken apart by tidal forces, the debris didn't fall inward. Instead, it spread out, caught between destruction and balance. Over millions of years, it formed the rings we see today. They are not permanent. Slowly, over time, the particles drift and fade. The rings may be a temporary gift, a moment in Saturn's long life that we are lucky enough to witness. Seen from afar, Saturn is a beacon of quiet beauty. Its rings glow in sunlight, catching and scattering the light in soft halos. No matter how many times we see them, they remain wondrous. A crown of ice in the kingdom of gas. Tiny sculptors. Though Saturn's rings appear still, they are always moving, always being shaped, and part of this shaping is done by tiny moons. These small, icy bodies orbit near or within the rings, using their gravity to push, pull, and guide the flow of particles. Some are called shepherd moons. They patrol the edges of the rings, keeping the particles in line. One such moon, Prometheus, tugs gently at the F-ring, pulling threads of ice into spirals. Another, Pandora, helps keep the ring's shape from unraveling. Together they act like invisible hands, sculpting patterns that drift and fade. Inside the rings, moons like Pan and Daphnis live within narrow gaps. As they orbit, their gravity creates waves, ripples in the ring's smooth structure. These waves move outward, curving the lines of ice, forming delicate grooves and ridges that stretch for miles. These moons are small. Most are no more than a few miles across, but their influence is great. Over time, their constant nudges keep the rings from falling into chaos. They are the quiet artists of Saturn's realm, shaping beauty without sound, sculpting order from dust. Even moons farther outplay a role. Mimas, with its cratered surface, sends gravitational pulses that stir the inner rings. Enceladus, with its icy plumes, adds fresh material, feeding the E-ring with particles from deep beneath its surface. Together, Saturn's moons are not just companions. They are caretakers, steady, silent forces that help the rings remain whole. In their movements, we see the delicate balance of gravity and time. Oceans below the ice. Beyond the rings, Saturn is surrounded by over 80 moons, each one unique, each one mysterious. And among them are worlds that hide oceans beneath their frozen shells. These are not oceans like ours, open to the sky. These are buried seas, warm and dark, sealed beneath miles of ice. Yet within them, there may be life, Enceladus is one such moon. Just 300 miles wide, it looks like a smooth white sphere, but at its south pole, something incredible happens. Cracks in the surface, called tiger stripes, shoot plumes of water vapor, ice particles, and organic molecules into
space.
These geysers spray into Saturn's orbit, creating the E-ring and hinting at a deep ocean below. Scientists believe that beneath Enceladus's ice is a salty, liquid ocean kept warm by tidal forces from Saturn's gravity. This ocean, rich with chemicals and warmth, could offer the conditions needed for life, even in the absence of sunlight. Then there is Titan, Saturn's largest moon, bigger than the planet Mercury. Titan has a thick atmosphere, rich in nitrogen and methane. On its surface, rivers and lakes of liquid methane carve channels and form basins, but deep beneath that surface may lie another ocean, made of water hidden beneath rock-hard ice. Titan is strange and beautiful. Its skies are orange, its lakes shimmer with hydrocarbons, and its potential for life, whether familiar or entirely alien, stirs the imagination. These moons, quiet and distant, are more than frozen rocks. They are worlds with layers, oceans that never see sunlight, places where warmth rises not from a star but from the embrace of a giant planet. In these secret seas, Saturn holds more than beauty. It holds the possibility of something living, waiting beneath the ice, a realm of dreams. Saturn is not the warmest world, not the brightest, not the closest, but it holds a special place in the human imagination. For centuries it has stirred dreams, a planet wrapped in rings, surrounded by moons, glowing softly in the darkness. In ancient times, Saturn moved slowly across the night sky. To early observers it became a symbol of time, wisdom, and distance. Later, as telescopes revealed its rings, it became something more, a wonder, a reminder that the universe holds beauty we cannot yet understand. Even now, with probes and satellites, with data and maps, Saturn remains magical. Images from the Cassini spacecraft showed us its storms, its shadows, its icy moons. They showed us sunlight shining through the rings. They showed us Earth, a pale blue dot, seen through the gaps in Saturn's halo. A tiny world, framed by silence. Saturn is more than gas and ice. It is art. It is structure and chaos in balance. It is motion without noise, a slow-turning masterpiece. When we dream of space, not as danger but as wonder, we dream of places like Saturn, places that remind us that the universe is not only made of fire and stone, but also of elegance, of patterns, of silence that stirs the soul. And in that silence, Saturn turns. Its rings spin, its moons orbit, and we, from our distant Earth, watch. We wonder, we hope, we dream. Chapter 11, Uranus, the Sideways World. In the deep, silent reaches of the solar system, where sunlight fades and space grows quiet, a strange planet drifts in gentle rebellion. Uranus, a pale, icy giant, does not spin like the others. It rolls. Most planets rotate upright with only a slight tilt from the vertical. Earth, for example, leans gently at 23.5 degrees. But Uranus is different. It lies nearly on its side, tipped at a dramatic 98 degrees. Its poles point almost directly toward the sun at times. It doesn't turn like a spinning top. It tumbles like a rolling ball, circling the sun in slow, deliberate grace. This extreme tilt sets Uranus apart, not just in motion, but in spirit. It breaks the rules without chaos, gliding in calm defiance of the solar system's usual rhythm. How it ended up this way remains a mystery. Perhaps long ago something massive struck it, a rogue planet or a colossal asteroid, knocking it off balance, or perhaps a slow gravitational tug over time turned its axis gradually. Either way, the result is a world unlike any other. This tilt changes everything. When Uranus rotates, it still spins, once every 17 hours. But because it is so tipped, one pole can face the sun for decades at a time, bathing half the planet in an endless day while the other half lies in a frozen night. Only after a long, slow orbit, 84 Earth years, do the roles reverse. From far away, Uranus looks peaceful. It is wrapped in soft, even colors with little visible motion. But beneath that serenity lies strangeness. It rolls through space on its side, steady, slow, and quietly bold, a tilted giant moving to its own rhythm. Whispers of blue Uranus is a world of gentle color, pale, icy blue, soft as breath, smooth as silk. Unlike Jupiter or Saturn, its surface shows little drama. No storms twist across its skies. No bands ripple in view. Instead, Uranus looks like a quiet marble floating in the dark. Its blue hue comes from methane gas in its upper atmosphere. Methane absorbs the red part of sunlight, allowing only blue-green tones to reflect back. But the colors we see are just the outer skin. Beneath those clouds lies mystery, layers of gas, ice, and shadow that remain mostly hidden. Uranus is made of hydrogen and helium, like the other gas giants, but it holds more water, ammonia, and methane ices deep inside. Scientists often call it an ice giant, a planet less like a cloud and more like a frozen ocean wrapped in gas. Beneath the calm upper layers, pressures rise, temperatures climb, and the gases begin to act more like liquids, dense, swirling, strange. No spacecraft has visited Uranus up close since Voyager 2 passed by in 1986. Even then, it only glimpsed the planet in a quick flyby. From that moment on, Uranus has kept its secrets. What winds move through its depths? What storms spin in the unseen? What patterns dance beneath the blue? Sometimes, from Earth, we detect hints of motion. Small storms, fast winds, flashes of heat. But they fade quickly. Like whispers carried on cold air, they vanish before we can catch them. Uranus does not reveal itself easily. It remains quiet, cool, distant, wrapped in blue mist, a planet that speaks softly, if at all. Seasons. Of eternity on Earth, seasons change with regular rhythm. Spring, summer, autumn, winter, each lasting a few months, repeating year after year. But on Uranus, seasons are stretched across decades. Because of its sideways tilt, Uranus experiences extreme shifts in sunlight. When one pole faces the sun, it remains in daylight for over 20 Earth years. The opposite pole is locked in night for just as long. Only near the equinoxes, when Uranus is sideways to the sun, does the light become more evenly spread. Imagine a sunrise that lasts for decades, a season where the sun never sets, a twilight that takes years to fade. That is the rhythm of Uranus. These long seasons affect the planet in ways we are only beginning to understand. The atmosphere may warm slightly under constant sunlight, winds may shift direction, as temperatures change over years. Subtle storms may form and fade across decades, but because Uranus is so far and so rarely visited, we only see fragments of its weather story. We watch it from afar, we track changes in brightness, we note slight changes in cloud structure, but the full pattern remains hidden, a song with verses too long for a single human life. The seasons on Uranus are not moments, they are eras. Generations could pass between one summer and the next. A child born during northern summer would see the start of winter only as an elder. That is the tempo of this world. Slow, majestic, and almost timeless. Uranus does not
rush. It moves through seasons as a glacier moves through valleys, steady, patient, unbothered by the ticking of short clocks. The hidden rings, Saturn's rings, shine like jewels, but Uranus holds its own circle of wonder. One harder to see, yet just as meaningful.
Uranus has rings too. Dark, thin, and faint, they hide in shadow, nearly invisible to the naked eye. But they are there, orbiting in quiet grace. The rings of Uranus were discovered in 1977, not by a telescope, but by accident, as a star passed behind the planet. Scientists noticed the star blinked in a pattern, blocked briefly by unseen matter. It was then they realized Uranus had rings, not glowing, but dark, not wide, but narrow. There are 13 known rings in total. Most are only a few kilometers wide, made mostly of dust and small rock. They lack the bright ice of Saturn's rings. Instead, they are likely coated in dark organic material, the product of radiation and time. Some are dense and well-defined, others are more diffuse, spreading like smoke through space. How did they form? Perhaps from shattered moons, broken by impacts, their pieces pulled into orbit, perhaps from captured debris trapped in Uranus's odd gravity. The rings do not tell us, but they hint. Like Saturn, Uranus has small moons near its rings. These moons may act as shepherds, helping to maintain the ring's shape. But everything here moves more quietly. No grand arcs, no shimmering halos, just faint curves seen only in the right light. They are easy to miss. But they are worth noticing. The rings of Uranus remind us that not all beauty shouts. Some wonders are subtle, seen only by those who look closely, patiently, with care. Uranus is a quiet world. It does not burn bright or spin in drama. It rolls slowly, draped in pale blue, surrounded by faint rings and silent moons. Its seasons stretch across lifetimes. Its storms are hidden in mist. Its tilt turns every expectation gently on its head, and in that stillness Uranus teaches us something rare, that even in the coldest places there is elegance, that even in distance there is presence. That being different does not mean being less. As the planet rolls through darkness, it carries its secrets calmly, a sideways world, turning softly through space, whispering stories only time can hear. Chapter 12. Neptune. Winds of the distant deep. In the far reaches of the solar system, beyond Saturn's grace and Uranus's tilt, a ghostly planet glides through the dark. Neptune, a world so distant, so veiled, that for centuries no one had seen it. And yet its presence was felt. Before Neptune ever came into view, its pull had already been noticed. In the 1800s, astronomers studying Uranus saw something strange. The planet wasn't moving quite as expected. Its orbit wobbled just slightly, as if an invisible hand were tugging at it from beyond. This mystery drew the minds of mathematicians. They studied the numbers, not the skies. Using nothing but calculations, they predicted where this unseen planet must be. And when telescopes turned to that patch of sky, there it was, exactly where the math said it would be. In 1846, Neptune became the first planet discovered not by sight but by logic, a world revealed by gravity's whisper, a triumph of human thought reaching across billions of miles. From the beginning, Neptune has been a planet of distance. It circles the Sun once every 165 years. It cannot be seen with the naked eye. Its light is dim, its presence quiet. Yet its gravity pulls, its winds rage, and its moons swirl in deep patterns of mystery. Even now we know little. Only one spacecraft, Voyager 2, has visited it, and only for a fleeting moment. But that moment changed how we see the edge of our solar system. Neptune, once a shadow in the math, became real. Blue, vast, and full of motion. It is a reminder that not all discoveries begin with sight. Some begin with a question, with a wobble, with the sense that something is out there, waiting to be found. A stormy symphony. Neptune may be far, but it is not still. Beneath its icy blue clouds, winds howl faster than on any other planet. Storms twist and spin through its thick atmosphere, dark ovals, white streaks, and towering clouds that stretch for hundreds of miles. The air is made mostly of hydrogen and helium, laced with methane, the gas that gives Neptune its deep, rich color. Sunlight barely touches this world. It receives less than 1,000th the light Earth enjoys, and yet it is alive with motion. Voyager 2, during its brief flyby, captured a storm known as the Great Dark Spot, a giant oval swirling in the southern hemisphere, similar to Jupiter's famous red spot. Winds near its edges reached speeds of over 1,300 miles per hour, faster than sound on Earth. That storm later vanished, but others soon took its place. New dark spots appeared. Bright clouds formed like cirrus ice in a hurricane. What fuels this wild energy so far from the sun? The answer may lie deep inside. Neptune gives off more heat than it receives, an inner warmth that bubbles outward, driving motion above. This heat, left over from the planet's formation, rises slowly, mixing the upper layers into fast-moving bands of weather. Some of the coldest temperatures in the solar system are found here, near the upper clouds, where particles freeze and winds scream. Unlike Earth's weather, which changes with the seasons, Neptune's storms seem to rise and fall without pattern. One moment, calm. The next, chaos. And then, once more, silence. These winds carry no voice. No sound reaches us from that far. But in their speed, in their shapes, in their colors, Neptune's storms compose a music of motion. A symphony without sound, played on the strings of gas and gravity. Triton's secrets, among the many moons that orbit Neptune, one stands apart. Triton, a frozen, lonely sphere, is unlike any other major moon in the solar system. It moves the wrong way. While most moons follow their planet's spin, Triton travels backward, a retrograde orbit. This tells us something important. Triton did not form around Neptune. It was captured. Long ago, Triton may have been a dwarf, planet like Pluto, wandering the outer solar system alone. Then at some point, It passed too close to Neptune. Gravity took hold. Triton was pulled in, trapped and reshaped. Other moons may have been flung away, and Triton settled into its strange backward path. Now it orbits in silence, spinning slowly in the cold. Triton's surface is pale, pinkish-white, covered in nitrogen frost. Its plains are smooth, but dotted with dark geysers, eruptions, not of fire, but of ice. Voyager 2 spotted them in 1989, tall black plumes of gas and dust rising miles into the sky, driven by sunlight warming frozen ground. This discovery made Triton only the third world, after Earth and Jupiter's moon Io, to show active eruptions. Beneath its icy crust, Triton may hold an ocean, liquid, salty, and ancient. Like Europa and Enceladus, its inner warmth could come from tidal forces. As Neptune tugs gently on the moon, its interior flexes, keeping parts of it warm. Triton is also shrinking. Slowly, it spirals inward, doomed to one day break apart or crash into Neptune. This fate is billions of years away, but the story is written in the math. Captured, changed, and moving against the tide, Triton is a reminder that not all journeys are straight. Some are pulled, curved, reversed. Some become something new. Even in a world of backward motion, there is beauty. There is mystery. There is meaning, the far, cold edge. Beyond Neptune, the solar system fades into shadow. No more bright planets, no more thick rings, only the Kuiper Belt, a frozen sea of rocks and ice drifting in the dark. Neptune marks the beginning of this realm. It is the gatekeeper of the deep. Beyond it lie dwarf planets like Pluto, Haumea, Makemake, and Eris. Comets, too. Long period. Visitors from the Oort cloud begin their journeys from this distant shore. Here, sunlight is faint. Warmth is a memory. Time stretches, and yet Neptune stands firm. Its gravity shapes the edge. It holds Pluto in a special orbital dance, a resonance where Pluto orbits the Sun twice for every 3 Neptune years. Though they never meet, they are locked in rhythm. The space beyond Neptune is not empty. It is scattered, slow, and wide. It is a place of beginnings, where the early solar system's pieces still drift. Neptune guards this edge like a lighthouse, not with light, but with presence, with mass, with motion. And it reminds us that the solar system does not end in fire or glory. It ends in cold, in distance, in silence that stretches beyond the reach of words. Neptune is a world of paradox. Cold, yet alive with wind. Distant, yet deeply connected. Invisible to early eyes, yet found through thought alone. Its storms rage unseen. Its moon moves against time. Its orbit brushes the solar system's final wall. It is the last of the giants, the quiet sentinel of the dark. And as it drifts, wrapped in blue and silence, Neptune speaks. Not in voice, but in gravity, in patterns, in beauty. A deep breath held at the edge of everything. Chapter 13. Pluto, the reimagined wanderer. Far beyond the familiar planets that bask in the warm light of the sun lies a realm of deep cold and silence. Out here, in the outermost reaches of our solar system, time seems to move slower. The stars do not twinkle. They hang in the sky like ancient, frozen fires. And in this quiet realm, Pluto drifts, a world of mystery wrapped in shadows. Pluto is not a place of bright colors or roaring storms. It is a world of stillness. Its surface is blanketed in ice, nitrogen, methane, and carbon monoxide, all frozen solid, forming vast plains and jagged mountains that glisten under the faint sunlight. At its heart, literally and figuratively, lies a vast glacier shaped like a heart. This region, called Tombor Regio, stretches across Pluto's surface like a soft, quiet symbol, as if the planet itself is reaching out, asking not to be forgotten. Temperatures here fall below 370 degrees F. Winds are gentle, almost
non-existent.
There is no atmosphere to carry sound the way it does on Earth. If you were to stand on Pluto, you would hear only your own breath inside your suit, the stars overhead, unmoving, the ground beneath your feet as silent as the grave. And yet, Pluto is alive. Beneath its icy crust, scientists believe an ocean might still exist, buried but real. Like a heartbeat under layers of frost, it pulses faintly, hidden from view, reminding us that even the coldest worlds may carry warmth within. This distant sphere, once seen as nothing more than a frozen rock, has revealed a quiet complexity. It is not a lifeless stone, it is a place of change, of subtle movement, of delicate beauty. New Horizons, a spacecraft launched in 2006, passed by Pluto in 2015 and sent back the first close images of its surface. What it revealed stunned scientists and dreamers alike. They saw smooth plains with no craters, meaning the ice was young. They saw towering mountains made of water ice, standing as high as the Rockies. They saw haze in the thin atmosphere, coloring the sky in gentle blues. In this world of shadows, light found a way, and in this forgotten corner of the solar system, wonder bloomed, the dance with Charon. Every world tells a story, but some stories are written in pairs. Pluto is not alone out there. Locked in an endless embrace with its largest moon, Charon, Pluto performs a slow, hypnotic dance through the dark. The two bodies orbit a shared center, not within Pluto, but between them in open space. It is a rare and graceful partnership. Charon is no small companion. It is more than half the size of Pluto, and together they make a kind of binary system, the only one of its kind among the planets and dwarf planets. Imagine two dancers, hands locked, spinning gently through a darkened ballroom. Neither leads, neither follows. They orbit each other with perfect balance. From Pluto, Charon would never rise or set. It would hang in the sky in the same spot, always watching. The same is true in reverse. Tidal forces have locked them together. As Pluto turns, so does Charon, always showing the same face. It's a quiet devotion stretched across millions of miles. Charon itself is grey and rough, scarred with canyons and valleys deeper than the Grand Canyon. Unlike Pluto's soft, icy plains, Charon's landscape tells a tale of ancient collisions and geological fractures. One side shows signs of resurfacing, ice that once melted and froze again, while the other remains cracked and rugged. Together, they tell a story of contrast, softness and strength, renewal and ruin. But it's not just about geology. The relationship between Pluto and Charon feels almost symbolic. In a part of space where loneliness seems guaranteed, Pluto has a companion. Their dance reminds us that even in the farthest reaches, connection exists. Even in silence, there is harmony. When New Horizons passed between them, it captured images of their shared twilight. Long shadows stretching across icy plains, blue haze curling at the edge of a black sky. It was haunting, beautiful, a picture
of stillness that seemed to breathe. In the dark, Pluto and Charon keep spinning, a quiet ballet no one watches, yet one that goes on anyway.
not for attention, not for praise, but because that is who they are, bound by gravity, bound by time. Together, a planet, redefined. For many years, Pluto wore a proud title, the 9th planet of the solar system. Discovered in 1930 by Clyde Tombaugh, it was hailed as a mysterious frontier, a world unseen but imagined, taught to schoolchildren, printed in textbooks, and nestled into models of the solar system with dignity. But as telescopes grew stronger and discoveries mounted, Pluto's place began to shift. Scientists found other small, icy bodies beyond Neptune, some nearly the same size as Pluto. The question became difficult. What exactly is a planet? And where should the line be drawn? In 2006, the International Astronomical Union made a decision that stirred emotions around the world. Pluto would no longer be called a planet. It would be reclassified as a dwarf planet. The news sparked headlines, debates, and even protests. For many, it felt like Pluto had been demoted, cast. Aside from a position it had held for over 75 years, children wrote letters, adults reminisced about their old school books. Why, they asked. Why take away its status? The answer, while scientific, couldn't satisfy everyone. Pluto hadn't changed, only our understanding had. But perhaps the redefinition wasn't an end, but a beginning. With its new title came new attention, new missions, new love. New Horizons was already on its way, but interest in Pluto surged. People wanted to see what had been lost, or rather, what was being reimagined. The flyby in 2015 revealed a world far more complex than expected. It had mountains, glaciers, winds, and maybe even an ocean beneath. Suddenly, dwarf planet didn't feel like a lesser term. It felt like a different kind of greatness, quiet, cold, and deep. The truth is, categories help us make sense of things, but they can also blind us. Pluto didn't become less beautiful when its label changed. If anything, it became more mysterious, more poetic, a reminder that names can shift, but wonder remains. And in the hearts of many, Pluto is still the 9th planet, not by rule, but by love. Beyond the names, what is a planet really? A ball of rock? A chunk of ice? A label in a textbook? Or is it something more, a feeling, a symbol, a mirror of our own curiosity? Pluto teaches us that exploration is not about boxes and categories. It's about reaching into the unknown and finding something that moves us. When the spacecraft New Horizons left Earth, it carried with it a message, a desire to know, not to judge. And when it reached Pluto, it found not a cold, dead rock, but a world full of secrets. Smooth plains where ice flows like lava. Mountains that rise from frozen water. A blue sky. A beating heart. And beside it, a moon that dances in time. We name things to understand them, but sometimes names fall short. What we feel when we look at Pluto, that quiet awe, that tug of wonder,
Cannot be captured in a category.
it's something deeper, more human. Pluto is more than a dwarf planet. It is a storyteller, a keeper of cosmic quiet, a guardian of the unknown. In its distant orbit, it watches, not with eyes, but with presence. It reminds us that there is still magic left in the solar system, that even the smallest places hold power. That being different is not a flaw but a gift, so whether you call it a planet or a wanderer, Pluto remains the same. Cold, distant, beautiful. A frozen dream drifting through the night. And though it may lie at the edge of our solar system in the minds of those who wonder, Pluto is always close, Chapter 14. The Kuiper Belt, the Frozen Frontier. Far beyond Neptune, where the sun is little more than a pale star, lies a vast and silent region, the Kuiper Belt. It stretches like a wide halo around our solar system, made not of fire or rock, but of ice. Here, billions of frozen bodies drift in slow orbits, untouched by time. This is the solar system's quiet edge, a sea of ice glowing faintly in eternal dusk. The Kuiper Belt is not a single object or place. It is a sprawling zone, home to countless icy fragments. Some are as small as pebbles, others are as wide as mountains. A few, like Pluto, are large enough to be considered dwarf planets. Together they float in a loose formation, not packed close but scattered far apart like snowflakes in space. The cold here is unimaginable. Temperatures drop so low that even gases like methane and nitrogen turn solid. There is no warmth, no wind, no atmosphere to speak of, just the deep dark and the gentle pull of the sun barely felt from this distance. These frozen objects, called Kuiper Belt objects, or KBOs, move slowly. Their orbits are wide, taking hundreds of years to complete a single trip around the sun. Unlike the bustling inner planets, life in the Kuiper Belt is calm, still, ancient. If you could stand on one of these icy bodies, the sun would not warm your face. It would look like a distant lantern glowing softly in the far sky. The stars would seem closer. Time would stretch, and around you nothing would move, just silence, broken only by your breath and the soft crunch of frozen dust beneath your boots. In this sea of ice there is beauty. Not the kind that sparkles or roars, but a quiet, enduring beauty. A reminder that even in the coldest corners of space, something waits, something old, something untouched. Relics of creation. The Kuiper Belt holds more than ice. It holds memory. These distant bodies are not just leftover. They are relics, ancient pieces, from the very beginning of our solar system. While planets like Earth were forged through collision and heat, the Kuiper Belt remained mostly unchanged. It is a museum of frozen time. Over 4.5 billion years ago, the sun ignited from a collapsing cloud of gas. Around it, dust began to swirl. Particles stuck together, forming clumps, then rocks, then protoplanets. But not all of it was pulled inward. Some was flung far out beyond Neptune's orbit. There, in the cold and quiet, it stayed. These frozen bodies carry the same material that once floated in the young solar system. Inside them lie clues to the chemistry of early space, to the process of planet building, and to the long history of our celestial neighborhood. They have not melted or broken apart. They have not been crushed or heated. They remain as they were since the beginning. Scientists study these objects not just to map the Kuiper Belt, but to understand our origins. Every icy surface, every crater, every chemical trace tells a story. Some KBOs contain organic molecules, the same kinds that may have helped spark life on Earth. Others show signs of past movement, of collisions that happened long ago and shaped their odd orbits. The New Horizons mission, which visited Pluto, also flew past another object in the Kuiper Belt, Arakoth. This small, peanut-shaped world stunned scientists. It looked like two pieces gently pressed together, barely disturbed since the solar system's birth. It was soft, pristine, peaceful. Holding Arakoth in our sights was like looking back in time, not in pictures or fossils, but in the real, untouched stone of space. The Kuiper Belt is filled with these messages, each one quietly whispering, "This is how it began." Hidden worlds. For a long time, we didn't even know the Kuiper Belt existed. Pluto was discovered in 1930, but for decades it seemed alone, a lone wanderer in the dark. It wasn't until the 1990s that astronomers started to find more objects like it. And since then, the number has grown into the thousands. Some are small. Others are large enough to challenge Pluto's size. Eris, Haumea, and Makemake, these are just a few of the new dwarf planets found in the belt. Each one is strange, each one unique. Some spin quickly, some are shaped like eggs, some reflect more sunlight than snow. Others are dark as coal, and yet we have seen only a small part. The Kuiper Belt is vast, and most of its objects are too small or too far to detect from Earth. They move slowly, they reflect little light, they hide in the dark. Even now, astronomers believe there may be more large objects waiting to be found, perhaps even something as big as Mars or Earth. These hidden worlds may orbit far beyond the Kuiper Belt, too distant to see clearly. Some call it Planet 9, though no one has seen it yet. But its presence is suspected. A shadow tugging at other orbits. A gravity we cannot ignore. Discoveries here don't happen fast. They take years of scanning the sky, tracking faint points of light. But each one adds to the picture, each one makes the map a little clearer, and the Kuiper Belt keeps surprising us. It reminds us that space is not empty. It is full of secrets, not loud, not obvious, but patient, waiting to be seen. The endless hunt. The search for understanding does not stop at Pluto, or at Arakoth, or even with Planet 9. Our curiosity pushes outward into the cold. The hunt for knowledge in the Kuiper Belt is slow, but it never ends. We send out telescopes, we launch spacecraft, we build better lenses and gather more light. Because somewhere out there, in the silent dark, answers wait. Why did the solar system form the way it did? Why are some orbits tilted, stretched, or strange? What else lies beyond Neptune and beyond the Kuiper Belt itself? These questions drive astronomers to study old data, to scan new sky charts, to track movements too small for the eye. The process is quiet, careful, like reading a book written in starlight. And the Kuiper Belt doesn't just offer answers about the past, it helps shape our future. The more we learn about these icy objects, the better we understand how planets form and what to expect around other stars. Every frozen rock out there might teach us something about alien worlds, about life, about survival in the cold. One day, we may send another probe deeper. A mission beyond Pluto, past Eris, into the edge where the Kuiper Belt fades into the scattered disk, and then the Oort cloud. There the true edge of the sun's reach begins. A place where the solar wind slows and space itself begins to change. That journey will take decades, maybe more, but the hunt continues because the Kuiper Belt is not just the end of our solar system. It is the beginning of the next question, the next mission, the next dream. And in the hush of that frozen frontier, we remember that space is not only about stars and fire. Sometimes it is about ice, about quiet, about the beauty of things that wait.
Chapter 15. The Oort Cloud, a Sea of Comets. Far beyond the planets, beyond Pluto, Beyond the Kuiper Belt, past the last frozen worlds and drifting icy bodies, lies the most distant part of our solar system. It is a place we have never seen.
Directly. No spacecraft has reached it. No telescope has clearly captured its shape. Yet scientists believe it surrounds us like a great invisible shell. The Oort cloud. The Oort cloud is not a solid ring. It is a vast sphere wrapping around the solar system in every direction like a gentle fog. It begins where the sun's warmth fades to almost nothing, somewhere around 2,000 times farther from the sun than Earth. And from there, it stretches out possibly 100,000 times the distance between Earth and the sun. In this cold, dim realm, the pull of the sun becomes weak, so weak that even nearby stars can tug at the frozen objects drifting through this space. It is here, at the very edge, that the solar system ends, and interstellar space begins. But even here, even in this quiet, dark ocean of space, the sun still whispers. Its gravity, though faint, still binds these icy bodies to our solar family. They are part of us, distant, silent, but still home. The Oort cloud is made of trillions of icy fragments. They drift in long, slow orbits that can take millions of years to complete. They are leftovers from the birth of the solar system, fragile bits that were pushed far from the sun in ancient times, left to sleep in the dark. This region is not a place of movement or warmth. It is a place of stillness, a boundary, a veil between what we know and what lies beyond. The Oort cloud reminds us that even home has an edge, a soft, fading border where our stars reach ends and the deep unknown begins. The ancient messengers. Every now and then a visitor comes, a spark in the sky, glowing with icy fire. A comet. Many comets that sweep through the inner solar system, lighting up the night with long, glowing tails, come from the Oort cloud. These ancient messengers begin their journey in the far, frozen dark. But something stirs them, maybe the gravity of a passing star or a distant pull, and they begin to fall inward, toward the sun. As they approach, the heat from the sun warms their frozen surfaces. Ice turns to gas. Dust lifts away, and what was once invisible becomes visible. A long, bright tail glowing in the sky. To us, comets are beautiful, mysterious, but they are more than that. They are carriers of memory. Inside each comet is ancient material and the same kind of dust and ice that formed our sun and planets over 4 billion years ago. Before Earth had oceans, before life, before time as we know it. When a comet passes close to Earth, we catch a glimpse of our own beginning. We see the frozen fingerprints of a time when everything was new. Some comets have names that echo through history: Halley, Hale-Bopp, Neowise. They've been watched for centuries, tracked across generations, and linked to myths and legends. But all of them come from the same distant sea, the Oort cloud. Some comets don't return. Their paths carry them around the sun only once before they are flung out forever. Others follow long, looping orbits that may take thousands or even millions of years before they return. Each one is a traveler, a messenger from the edge, a quiet voice from the deep past, arriving softly in the present. Frozen guardians, the Oort cloud is not just a distant shell, it is also a kind of shield. Because it surrounds the solar system in every direction, the Oort cloud acts as a barrier between us and the galaxy beyond. Most of the time, it simply floats, undisturbed. But sometimes, stars pass nearby, or waves of gravity ripple through space, sent from ancient explosions far away. When that happens, the icy objects in the Oort cloud can shift. Some may fall inward, becoming comets. Others may scatter, absorbing the energy and softening the blow. In this way, the Oort cloud protects the inner planet, including Earth, by taking the hit. It is like a vast field of quiet guardians holding the edge, but its role goes deeper. Scientists believe that, long ago, the Oort cloud helped shape the solar system itself. In its early days, the Sun was surrounded by a chaotic disk of gas and dust. As planets formed, their gravity flung some of the leftover pieces far outward. These scattered fragments became the Oort cloud. In doing so, they helped settle the solar system's balance. They removed energy, they calmed the orbits of larger bodies, they gave shape to what we now call home. And today, as the solar system drifts through the galaxy, the Oort cloud moves with it, like a soft bubble gliding through space. It cannot stop everything, but it offers a cushion, a silence that protects. It is not a wall, it is not armor. It is something quieter, a field of watchers, frozen in place, standing between us and the dark beyond. A circle without end. The Oort cloud may be the farthest part of our solar system, but it is also a place that reflects its heart. It holds the beginning, the ice and dust from the birth of the sun. It touches the end, the place where our star's light fades. And in its slow orbit, it shows the timeless rhythm of space, of cycles, returns, and endless motion. When a comet falls from the Oort cloud, it completes a great loop. It begins in stillness. It is stirred by some small force. It moves inward, flares with light, and then returns, or disappears. The journey is slow, vast. But in its path we see the shape of time. The Oort cloud is a circle, not in shape, but in meaning. A reminder that things are connected, even across distance. That what begins far away may one day return. That endings are often beginnings in disguise. We may never see the Oort cloud up close. It may remain a theory, a shape drawn from hints and shadows. But even unseen, it shapes our world. It cradles our system like a soft shell. It offers comets that spark wonder.
It marks the outer edge of what we know and the first step into what we don't. And perhaps in that way, the Oort cloud is not the final chapter of our solar story. It is the bridge between warmth and cold, between light and dark, between
the familiar and the unknown, as Earth spins, as comets pass, as stars drift in the distance. The Oort cloud remains, silent, steady, holding the edge, and beyond that edge, the galaxy waits. Chapter 16. Black Holes, Secrets Beyond Light. Every star tells a story. It begins in a cloud of gas, grows bright through fusion, and for most stars ends gently, fading into a quiet ember. But for the most massive stars, the ending is not quiet. It is not gentle. It is the beginning of something darker. When a giant star nears the end of its life, its fuel runs out. Fusion slows. The core, once hot and bright, can no longer hold itself up. Gravity takes over. The star begins to collapse inward, folding into itself under its own enormous weight. This collapse is fast, violent. Everything is pulled toward the center. Atoms, light, space itself. In just moments, the core shrinks beyond measure until it becomes something no one can see. A point with no surface, no volume, only gravity. A black hole is born. At first, there is chaos. The outer layers of the star explode outward in a supernova, a final burst of light and matter. But what's left behind is silent, a shadow. Not a thing exactly, but a place where the rules of the universe change. Black holes are not holes. They are regions of space where gravity is so strong that nothing, not even light, can escape. They are the final stage in a star's journey, the point at which matter becomes memory. The moment when something crosses over and never returns. Though black holes are born from death, they are not dead. They do not end. They remain, holding the memory of the star that created them, shaping space long after the light has gone out. And in the quiet of the universe, they drift, unseen, unfelt, waiting, the quiet architects. Black holes may be invisible, but they are not empty. They are heavy, unimaginably heavy. And in space, mass means influence. Black holes bend space around them. They twist the paths of stars. They slow time. They shape the galaxies themselves. At the center of nearly every large galaxy, including our own, lies a supermassive black hole. These are giants, millions or even billions of times heavier than our sun. They do not roar, they do not shine, but their pull is mighty. Around these black holes, stars swirl like water circling a drain. Gas collects and heats, forming glowing rings. Light dances at the edge, only to disappear forever. These black holes act like anchors. They hold galaxies together, helping them spin and grow. Without them, galaxies might not form at all. Their gravity brings order to the stars. They are the quiet architects of the cosmos. Even though black holes can tear matter apart, they also create structure. The material that falls toward them can spark new stars. Their gravity keeps gas clouds moving, feeding life into their galaxies. They are not destroyers, they are sculptors, carving the universe with hands we cannot see. We rarely notice them because they do not speak in light, but their presence is known. We see stars orbiting nothing. We see radiation from gas that spins.
Too close.
We see their shadows against the stars. In this way, black holes guide the story of the universe, not with light, but with gravity. Not with noise, but with presence. The event horizon. A black hole is not just a dense object. It is a region with a boundary called the event horizon. This is the edge, the point of no return. Outside the event horizon, things can escape. Light can travel, time flows normally, but once anything crosses this invisible line, it is gone, pulled inward forever, unable to return. Not even light can break free. The event horizon marks the end of space as we understand it. It is not a surface, but a boundary, a one-way door into the unknown. As something approaches the event horizon, strange things begin to happen. Time slows down. From far away, it looks like the object freezes, never quite crossing the edge. But to the object itself, the fall is swift, silent, and final. No one knows what lies inside a black hole. The laws of physics break down. Some say everything is crushed to a single point, a singularity. Others believe space and time twist into something we cannot imagine. What we do know is that information seems to disappear. Mass is pulled in, light is lost, and all that's left is a shadow in the sky, a perfect black circle surrounded by a halo of light from the gas and dust swirling nearby. This boundary, the event horizon, is not a wall. It is a question. A place where knowledge stops, where certainty ends, where the universe holds its breath. Mirrors of mystery. Black holes are not just cosmic objects. They are reflections, mirrors of the universe's deepest questions. They ask, what is space? What is time? What happens at the edge of reality? They show us that gravity is not just a force, it is a curve in space, a bend in time. They remind us that light can be trapped, that time can slow, that the universe is stranger than it seems. Even as we learn more about black holes, through telescopes, through theories, through images of their shadows, they remain symbols of mystery. They carry secrets of the beginning. In the early universe, black holes may have formed quickly, shaping galaxies from the start. They may hold answers to how the cosmos evolved, how stars live and die, and what lies beyond the edge of understanding. Some believe black holes are tunnels, connecting distant parts of the universe or even other universes entirely. Others wonder if they contain lost information waiting to be released. We do not know, and maybe we never will. But that is part of their beauty. Black holes remind us that science is not just about answers. It is about wonder, about reaching into the dark, not to control it, but to listen. They are not just endings. They are beginnings. Places where the known gives way to the unknown. They float in silence. They curve the light. They mark the edges of maps we have yet to draw. And in the stillness of the universe, black holes remind us that some things are not meant to be solved, only seen. Respect Chapter 17, The Big Bang, Where It All Began. Long before stars, long before time as we know it, long before even space itself, there was something else. Not a place, not a sound, just a point. A single moment so small it defies imagination, and so full it carried everything. This is where the story begins. Not with noise, but with silence. Not with form, but with potential, a singularity. In this beginning, all of the energy, all of the matter, all of the space and time that would become the universe was pressed into one single point. Smaller than an atom, no width, no height, no depth, no before, no after, just everything, waiting. Then, in an instant, it changed, not like an explosion you'd hear or see. There was no air to carry sound, no space to hold a flame. It was the sudden expansion of everything from almost nothing. This was the Big Bang, the moment when the universe, so tightly held in silence, began to unfold, not into space, but creating space itself. Time began to tick. Distance began to stretch. The laws of physics began to form. In the earliest moments, within the first second, the universe grew from smaller than a grain of sand to larger than a galaxy. Not in one place, but everywhere, all at once. Like ink spilling into water, it expanded smoothly and endlessly, reaching outward in every direction. But this wasn't chaos. This was the beginning of order, and in that silent, invisible moment, the foundation of everything was laid, the great expansion. As the universe stretched, it cooled, From the heat of 1 trillion suns, it softened into something calmer. Protons formed, then neutrons, then electrons. And slowly, these pieces began to find each other, building atoms, mostly hydrogen, some helium, simple, quiet ingredients. For a long time, the universe remained dark. There were no stars, no galaxies, no light that could shine. Just gas drifting through a soft, expanding sea. But even then, gravity was at work, gently pulling atoms together, little by little, cloud by cloud. Over millions of years, those clouds became dense, pressure built, temperatures rose, and then stars were born, tiny fires in the cosmic dark. These first stars were massive and hot. They burned quickly, living short but brilliant lives. Inside them, simple atoms fused into heavier ones, carbon, oxygen, iron. And when these stars reached the end of their lives, they exploded, sending those new elements out into space. Galaxies formed, spiraling through the cosmos. New stars ignited, planets began to form around them, built from the ashes of earlier generations. It was a grand cycle, shaping everything. Over billions of years, this expansion continued, calm and steady. Galaxies drifted apart. New stars were born. Some places became crowded, others stayed quiet. The universe aged with grace. And somewhere, in this slow-blooming, teed-on-small blue planet, life began. A quiet heartbeat in the middle of a vast, growing sky. The echoes of light. Even today, the early moments of the Big Bang still echo around us. They are not loud, they are not bright. They are whispers, soft and ancient, carried in the light that fills all of space. This light is called the cosmic microwave background. It is the afterglow of creation, the heat left over from when the universe was just a few 100,000 years old. At that time, the universe had cooled enough for atoms to form without being ripped apart by energy. Light, once trapped in the fog of particles, was suddenly free to travel. And it has been moving ever since, stretched thin by the expansion of space, cooled by time, but still present. We cannot see this light with our eyes, but special instruments can. It fills the sky evenly, coming from every direction. It is the same everywhere, a quiet signal, gently humming at a microwave frequency. Discovered in the 1960s by accident, the cosmic microwave background changed how we understand the universe. It was the first real proof that the Big Bang happened, a leftover warmth from the very first moments. But more than that, it holds detail. Tiny ripples in the temperature of this light show the seeds of galaxies, small differences in density that grew into the stars and planets we know. The echoes of light are not just a memory. They are a map, a picture of the universe when it was still an infant, only 380,000 years old, and that picture still floating around us reminds us of just how far we've come. Forever beginning. The Big Bang was not just a start, it was a
rhythm, a motion that never ended. Space is still expanding, galaxies are still drifting.
Time is still unfolding. Even now, more than 13 billion years later, the universe continues to grow. The space between galaxies stretches, the light from distant stars shifts to red. The cosmic clock keeps ticking, not toward an end, but through change, and in this we see something beautiful. Every ending in the universe gives rise to something new. Stars die, but from their dust, new stars form. Planets break apart, but their pieces join other worlds. Even silence leads to motion. Even darkness gives way to light. The Big Bang did not just happen long ago. It is still happening, not in a sudden burst, but in every quiet expansion, in every gentle unfolding. We carry it within us. The atoms in our bodies were forged in stars that trace back to the first light. The space we live in was born in the first breath of time. And as we look into the night sky, as we follow comets, study galaxies and dream of distant worlds, we are, in a way, returning home. Back to the moment when everything began. The Big Bang was not a bang at all. It was a bloom, a soft, powerful beginning, the start of space, of time, of story. And as long as the universe continues to stretch, to form, to breathe, that beginning never truly ends. It is always becoming, always beginning. Chapter 18. The Solar System's Future. Dreams Beyond Time. In the quiet future of the solar system, the sun will still shine, but not as it does today. Billions of years from now, it will begin to change. Slowly, gently, like a long, fading twilight that touches every world it once warmed. The sun is a middle-aged star, steady and calm, but stars have lifespans, and our sun is no different. For now, it fuses hydrogen into helium deep within its core, releasing light and heat that reach all the way to the edge of the solar system. This process has continued for billions of years, but it cannot last forever. Over time, the sun will run low on hydrogen. The core will shrink, growing hotter and denser, while the outer layers expand outward. The sun will grow larger, brighter, redder. It will become a red giant, a vast, glowing star, far bigger than it is now. This transformation won't be sudden. It will unfold over millions of years, like a slow sigh. The sun's heat will change, its rhythm will falter, and the planets that once danced calmly around it will feel the shift. From Earth, if it still exists, the sky will brighten with a strange orange glow. The sun will swell, filling more of the horizon each day. Temperatures will rise. Oceans will boil. The atmosphere will thin. Life, as we know it, will struggle and eventually fade. But the sun, though older, will not be angry. It will not roar. It will bloom into its next form with quiet majesty. A gentle farewell from a star that once nurtured life on a small blue world. Farewell to worlds. As the sun expands, it will touch the inner planets. The changes will not be kind. Mercury, already scorched by the sun's heat today, will be the first to go. It will be swallowed by the sun's growing outer shell, melted, torn apart, and lost to the fire. Venus will follow soon after. Once shrouded in thick clouds, its surface will vanish beneath the red tide, its mountains and valleys erased. And Earth? Earth's fate is more delicate. Some models suggest that Earth, too, will be consumed, drawn into the burning giant that the sun will become. Others suggest that it may just escape, pulled into a wider orbit by the loss of the sun's mass. But even if it survives physically, it will not survive in spirit. The oceans will vanish into steam. The air will thin and escape into space. The land will crack and dry, and the blue that once marked this planet will be gone. Forests will fade to dust. Cities will crumble. The sky will no longer host birds, nor will the wind carry laughter. Earth will become silent, a memory in stone. Mars might endure longer. Its distance could spare it for a time, But even there, warmth will become a threat, not a gift. Ice will melt, but not for life. Atmospheres will escape. The soil will dry. The planet that once held dreams of life will fall into shadow. The outer planets, Jupiter, Saturn, Uranus, and Neptune, will remain distant enough to survive. But they too will change. Their moons may warm. Icy surfaces may melt. Strange new climates may appear briefly before fading once more. The solar system we know, a system of variety, of warmth and wonder, will become something else, older, quieter, marked by the long goodbye of its central star. The new dawn, yet even in loss, the universe writes new stories. After the red giant phase, the sun will shed its outer layers into space. The glowing shell of gas will drift outward, becoming what we call a planetary nebula, a soft, colorful cloud floating through the void. And at its heart, what remains of the sun will be a white dwarf, small, dense, and quiet. No longer a furnace, but a fading ember. This will be the sun's final form, a soft white point of light slowly cooling over trillions of years. It will no longer power planets or light skies, but it will remain a symbol of what once was. But by then, what of life? It is possible, perhaps even likely, that life will have moved on. Long before the sun begins to expand, thinking beings, whether human or otherwise, may find new homes among the stars, new planets, new suns, new skies to live beneath. Distant descendants of Earth may witness the red giant sun from far away. They may remember their origins not through books or monuments, but through stories passed from one world to another. They may build cities under alien moons, sail through clouds on gas giants, create new meanings for stars yet to be named. They may speak of Earth the way we now speak of ancient forests or sunken cities, not with sadness, but with wonder, for every ending in space makes room for something new. The death of stars brings light, the fading of warmth gives rise to questions, and life, if it endures, will not be a guest of Earth alone. It will become a traveler, a witness, a storyteller beneath unfamiliar skies, written in stardust. Even if Earth vanishes, even if the sun dims into silence,
Even if every monument fades, there may still be something left behind. Humanity's legacy, like the atoms in our bones, is made of stardust. And dust does not vanish. It drifts. Our signals, our machines, our stories, they may outlive us.
spacecraft like Voyager 1 and 2 already travel beyond the reach of the planets, carrying golden records with greetings, music, and memories of Earth. They float silently, untouched, sailing into the unknown. Perhaps one day, someone or something
We'll find them.
They may not understand our languages or images, but they will know that we were here, that we looked up, that we wondered. And even if no one ever finds them, these messages carry a quiet truth, that for a time life opened its eyes on a small world, that it loved and dreamed, that it reached beyond the sky not to conquer, but to understand. Like pollen riding the wind, our legacy may scatter, in fragments, in echoes, in dust, and perhaps in some far corner of the galaxy a piece of Earth will help spark a new world, a spark of memory, a trace of story, a whisper of home, because in the end the solar system is not just a place, it is a chapter in the great book of the cosmos. One story among many, beautiful, brief, and deeply meaningful. The sun will sleep, the planets will fade, but the dreams they once held may continue, traveling with the dust carried by the stars. Chapter 19. A Cosmic Reflection. Sleep beneath the stars. Somewhere in the stillness of night, beneath the soft glow of distant stars, a quiet truth waits. A truth older than the earth, older than the sun, older than memory. Every atom in your body was once part of a star. Long ago in the young universe there were only simple elements, hydrogen, helium, drifting through space like soft mist. Then came the stars, massive, radiant furnaces that turned lightest elements into heavier ones, carbon, oxygen, iron, the very building blocks of life. When those stars grew old, they did not simply fade. They exploded, gently in some cases, violently in others. They cast their insides across the cosmos, scattering the elements they had forged: dust, ash, light. These fragments drifted through space, mixing, swirling, falling into new stars, new planets, new beginnings. Eventually they came together in a cloud that would become our solar system. Earth formed from this cosmic dust. And on it, life appeared, quiet at first, then vibrant. And somewhere along that journey you were formed, the calcium in your bones, the iron in your blood, the oxygen in your breath, all born from stars that lived and died long before Earth was born. This is the tender truth of existence. We are not separate from the universe. We are part of it. Not visitors beneath the stars, but reflections of them. Not beneath them, really, but of them. When you look at the night sky, you are not just looking out. You are looking in. The endless story. The universe tells a story, one that never truly begins and never really ends. It's written in starlight, carried in gravity, whispered by comets, painted across galaxies. Every galaxy is a chapter, every planet a page, every star a word, and Earth. Earth is a single line in the great unfolding tale of time, but a beautiful one. It's a place where the cosmos became aware of itself, where stardust opened its eyes, where questions were asked and names were given to light. Our journey, the journey of life, mirrors the universe itself. We begin in darkness. We grow through pressure and change. We shine for a time. And then, gently, we return. Stars are born. They burn. And then they rest. Galaxies spin. Nebulae drift. Time stretches like silk. And through it all the universe continues. Steady, vast, and unhurried. And within this story, we are both tiny and grand. A moment, yes, but a meaningful one. Because in all the known universe, only here, only now, do we tell this story in words. Only here do we wonder, dream, and imagine. Our journey is not separate from the cosmos. It is part of its rhythm, the falling of stars, the bloom of galaxies, the breath of life on a blue world turning slowly through the dark, the song of the spheres. If space had a sound, it would not be noise, it would be silence. But not an empty one. It would be like the hush of a forest at night, or the stillness of a sea before dawn. A silence that holds meaning. A silence that breathes. The ancient Greeks spoke of the music of the spheres, the idea that planets and stars move in harmony like notes in a grand celestial song. We know now that planets do not sing, yet in their orbits there is rhythm. In their paths there is grace. Jupiter, massive and slow. Mercury, quick and darting. Saturn, encircled by light. Neptune, serene and cold. Each moves in time, each follows, a curve drawn by invisible lines. Together they perform a dance older than memory. The moon rises, the tides follow. Earth spins. The seasons change. The stars drift overhead, returning to the same places as if remembering something. This is the music of the universe. Not sound, but pattern. Not noise, but balance. A gentle choreography that continues night after night, age after age, and in this dance, we find peace. We remember that we are not lost. We are moving, slowly, softly, through a design far greater than we can hold. There is no rush in the sky, no panic in the stars, only calm, only flow. Dreams beyond the night, now as your eyes grow heavy, and the world around you softens, let the stars carry you. Close them gently. Let go of the weight of the day. The questions unanswered, the stories unfinished, the paths not taken. They can wait. Tonight, there is nothing to do, no place to go, only the soft hum of the earth turning, only the quiet above. Imagine yourself beneath an open sky. The grass cool beneath you. The stars above, watching gently. Each one a beacon from a different time, a different place. A quiet promise that the universe is wide and kind. Let yourself drift past the clouds, past the moon, through the rings of Saturn gliding slowly, past Pluto quiet and cold, out beyond the Kuiper belt, into the soft edge of the Oort cloud, where comets sleep, and farther still, where stars become rivers, where galaxies drift like petals on wind, where time slows, and your breath is part of the night. This is not the end of the journey. It is a pause, a breath, a rest in the rhythm of the cosmos. Tonight, you are not alone. You are among stars. You are made of them. You are held by them. So sleep. Dream gently, and when you wake, the stars will still be there, quiet, ancient, watching. Their light traveled billions of years to reach you, and you, in turn, will carry that light forward, in your thoughts, in your wonder, in your dreams. Sleep now, child of stardust. The universe is watching, and it is at peace. Peace.